for this formula. So n equals z star over e squared times p times 1 minus p. Okay? Now we know what e is, because I gave you that in the problem, right? The margin of error we want is 0.01. So this thing is 0.01. We also know what z star is, right? I wanted a 90% confidence interval, and all that z star depends on is that number 90%. So we can use the same z star that we had in the previous problem. Okay, this thing does not change, it's still 1.645. And now the question is, what do we use for p? Right? We haven't taken any data yet because we don't even know what the sample size is. And so yeah, the question is, what can we plug in for this value p? And so there's two ways to get about this. So the question is, what is this p? So there's two options. So one is just take a guess. Maybe you've done previous computations, previous estimates for p hat, and so you could use whatever estimate you had before. But another thing you can do is you will always overestimate this number n by using p equals 1/2. Okay? So we can always just plug in 1/2 for this value of p, and that'll give you an overestimate for n. So at least you'll get, a margin of error smaller than what you want. You get something better. And so let's quickly, do that for our problem and then see why this is true. So using p equals 1/2. And also I should mention, statisticians have really great notation. In this formula they usually use p star for the guess. So there's p hat, and p star. I don't blame you if you can't keep them straight. So let's use p star equals 1/2. This gets us n equals 1.645 over 0.01. We're squaring that fraction. And then we're multiplying by 1/2 and by 1 minus 1/2. Okay? And so if we plug this into our calculator, we get n equals 6806.7. Okay, but you can't take 0.7 of the sample, so we just round up. So we always round up. our n, and we get n equals 6807. Okay, any questions about how we got this n? Okay, so for the last couple of minutes, let's try to figure out why 1/2 always gets us an overestimate. So the quickest and maybe least satisfying answer is if you just plot the function y equals x times 1 minus x, this function has a maximum at 1/2. It's this parabola, and the biggest value it takes on is over here at 1/2. So the biggest possible value we could have for this term here is by plugging in 1/2. So that's one explanation. Another explanation is if your p is 1/2, that is as uncertain as you can possibly be about the situation, right? If p is not 1/2, somehow you have more certainty about what's going on. You have some expectation about whether any given potato will be defective or not. But you maximize uncertainty by using p equals 1/2. Okay, so you have no idea if a given potato you pick up is going to be a defect or not. And since you have no idea, that means you're going to need more data to have certainty in your predictions. So you can think of using p equals 1/2 as maximizing uncertainty, and that means you need more data. Okay, so we're going to do, I forgot again. I have everyone's old quizzes and homeworks. You can come pick those up.